find the z-scores that separate the top 10% and bottom 10% of all values. We can imagine on our graph we're looking for the z-scores that would fall around here and here, where above that z-score there is 10%, and below that z-score there is also 10%. So for instance here, this would have an area of 0.10 to the right of that z-score, and this one would also have an area of 0.10 to the left of that z-score. So here, because we're given the area and we want to find the associated z-score, we're going to use the inverse norm. With an area of 0.10. And we got to be careful here, because when we choose left, right, if we're choosing left, then we're going to be computing this z-score here. And if we choose right, we're going to be computing this z-score here. So we'll get two different z-scores depending on if we're choosing left or right. So when I choose left, it's going to give me the negative z-score. So let's see if I choose left. It gives me negative 1.282. So here that makes sense, because it looks like here we would definitely have a z-score that's to the left of 0, so it's negative value. Notice that when I do the right, because of the symmetry in the graph, you'd get the same value in this case, but a positive version. So you would get positive 1.28. So at a z-score of negative 1.28 and positive 1.28 is the z-scores that separate the lower 10% and the top 10%. In the example below, they're having us compute a critical value. And a critical value, denoted z alpha, denotes a z-score with an area of alpha to its right. And in this case, if I, for instance, I'm looking for z of 0.05, so here we're looking for a z-score that has an area of 0.05, so maybe something around here. It has an area of 0.05 to the right of it. And so when we're calculating this z alpha, we're going to use the inverse norm again, since we're given the area and we want to find the associated z-score. So in this case, an area of 0.05. 0, 1, because it's a standard normal distribution whenever we're talking about z-scores. And then in this case, we'll use the right. So our inverse norm here, when we do it, put 0.05 for the area, 0, 1 for the mean and standard deviation, and we get something about negative 1.64. Or actually, in my case, positive 1.64, because again, we're doing the right tail there. So in my calculator, because I only have the option of doing the left, it's going to, by default, compute the area that's to the left. So it would actually give me the negative version of my answer. But in this case, if you have the option of putting in right, it'll give you the positive version. So in this case, a z-score of 1.64.